All right, so one of the major uses for all this is optimization. Because we've been talking about what the heck? I don't know what I spelled. We've been talking about maximums and minimums for a while. So using derivatives, you can maximize or minimize pretty much any function. And that becomes useful when these functions represent like costs or profits or whatever. Man, I'm out of it today. Keep writing the same thing. Automation. All right. Let's see. Is okay. So let's start off with the example. In this section and on the exam, you have to have your formulas handy or memorized, but stuff like perimeter of a rectangle, area, volume of a cylinder or sphere, all that stuff. It'd be nice if you knew it, but if not, just put it on your formula page. Okay. So let's do one example and show you what I'm talking about. Find the length and width of a rectangle that has the given perimeter and the maximum area. So basically, just put it in simple terms. You know what the perimeter is going to be. So let's say, I don't know, someone tells you, hey, I need a fence. I only have this much material, so do this perimeter around, but I wanted to have the maximum amount of area. Okay. So this is how you would do it. Of course, they have to give you perimeter. So we need to maximize, right? They're telling us to maximize area, so we should do derivatives on area in just a moment. Let's write the stuff down that they're going to give us. Okay, so they're just giving us perimeter. But they also said rectangle. So we should know that the perimeter of a rectangle is 2L plus 2W. Area is length times width, right? Y'all agree? Yes. Okay. So, when we're doing these derivatives, we want to do it when we're optimizing, we want to do it on a single variable. So use the perimeter here and the given fixed perimeter, the requirement, to get it into one variable. So basically what I'm saying is solve for L or W, doesn't matter. All right. I'm gonna solve for L, I guess. Divide everything by 2. I'm gonna divide it by 2. Okay. So L will be equal to 36 meters minus W. So use this fact, right? So plug this into the area formula. Okay, so here we go. So we know that area is equal to length times width, right? So that means that area is equal to, right, get everything in terms of W, I guess, when I substitute L, right? So now now area formula is a quadratic. Okay. So we'll take the derivative with respect to width of the area. So derivative of A with respect to W is equal to the whole thing ddw, right? So this will become so dAdw is equal to 36 minus 2W. Okay. All right, so I'm going to slow down here. You guys still with me up to this point? Do you see where we're headed?
Yes.
Any questions? Okay. So we found the derivative. Now, if we set the derivative equal to 0, we'll find the critical numbers, right? And that should be where we have a minimum or maximum. So set this to 0, find the critical number, and then check. Is it a maximum or is it a minimum? Okay, I'm out of space though. Let me add some notes here. Okay, some notes for later. So set the derivative equal to 0, then find your critical numbers. All right. So 36 minus 2W equal to 0. That means that 36W will be 18, right?
Yes.
You have a question about algebra, let me know. All right. Okay, so we have the critical number. So now we'll say use the first derivative test to determine if W equal to 18 is a max slash minimum. Right, because remember what we've done a lot, right? So the idea, we're trying to find the width that will help us maximize our area of our fence or whatever. Okay. Or rectangular area. I'll use some easy points. 19, I guess. Let the formula one more time before I forget. Okay. So at 0, do you agree that it is positive? Right?
Yes.
What about 19? Negative, right? 2, is that right?
Yes. Yes.
All right. So we have increasing and then decreasing. So what do we have? Right, this is a maximum, right?
Oh yeah, he's max
So max area when W is 18 and L was equal to what? 36 minus W. So also 18. It turns out that in this specific example, with this specific perimeter, having a square fence was best. So not that interesting, but the process is what matters, right? Let's start over from the top rope. There's a big summary here. The first thing we do is figure out, okay, what exactly are they talking about? What is the shape? It was a rectangle, so I got these two things ready for the problem. They said maximize area, so I'm like, okay, well, I need to get this stuff into, I need to focus on this, but it's best to get it into one variable if possible. So I use perimeter to turn this into a simple question and then start my derivatives. So here's the solving for L, plug in L in, simplification, derivative of a area function, which is this. So in order to maximize area, you take a derivative and set it to 0, right? Which is what we did here. Solve for W, got 18. We need to make sure that it is a max, so I decided to use my first derivative test. You could have used second derivative test if you wanted to, because this one's pretty easy, right? Um, but you would see right away that this is a minimum. Once we know what it is, we still need the length because we solved L in terms of W. So plug in the W to get your other dimension. So now we have 2, and we're good. Any questions on the process and the main idea? Or the calculus or the algebra? Okay, cool. All right, well, that's how you optimize these types of questions. Let's do another one a little harder. Let's see. Yeah, let's do example 2 here. I think it's one of the first few questions in the homework. They'll be very similar. The only difference is instead of being given perimeter, they're giving us area. and they want us to minimize the perimeter. So it's kind of the opposite. Let's see, 1 second. Find the length and width in feet of a rectangle that has the given area and a minimum perimeter. All right. All right, so just to make it simple and shorter, I'm going to write down the area here. So the area of the rectangle is 16 feet, I guess, feet squared. And I think that's all we need. Write down our formulas. Yeah, so pretty much the same exact thing. Sorry, I was lost in thought. It's just in reverse, right? You guys see what's happening? We'll solve for, I guess we'll solve for the same thing again. Solve for length. So L will be equal to 16 over W, right? You guys agree?
Yep.
Plug that in here. And you'll have perimeter in one variable, and then we can do derivatives. So that'll be P equal to 2 times 16 over W, which is weird, plus 2W. All right. Which is the same as 32W negative 1 plus 2W. You guys agree? Okay. So take a derivative of this guy is a little easier. dp dw, I'm sorry, yeah, dw equal negative 32 w negative 2 plus 2. Excuse me. All right, guys, cool with the derivative. Let's skip the little step here. So let me know. Set the derivative to 0.
I have a question.
Yeah, what's up?
So let's say we're taking the derivative of like for example, 32w with a power of -2. Would we multiply the number by the power of -2 or just negative?
Yeah, it would be negative 2. So if this was currently negative 2, you would have negative 64 over here and a negative 3 there.
Okay, thank you.
Yeah, you're right. and find crits. All right. So negative 32W, negative 2 plus 2 equal to 0. Now that would be 32W negative 2. Oops. Equal to 2. That's the easiest way to do that. I guess this would be the same as 16 equal to W squared, right? I skipped an algebra step. Is that cool with you here? Solve for W. Alrighty. So W is equal to plus or minus 4, right? When you square root both sides. Uh, Let me show that work. Okay. You guys still with me up to this point? So these are your critical numbers. Which one would you choose to use? Because we got two.
The larger one.
Yeah, positive, right? Because this is a width, so negative width doesn't make any sense. So use the positive dimensions. All right. You guys cool so far? I'm gonna go to the next step. Just let me know. So we found width to be 4 feet. So what does that mean for length? What's length gonna be?
4 feet.
Yeah, same thing, right? Okay, so it turns out that because it's a semi-simple question, it's another square. Oh well, who cares? So the length we want is 4 and the width we want is 4. But that's all they asked for, right? They said, back to the question, they said, find the length and width in feet of a rectangle that has a given area. So it does have this area. And I did ensure that the perimeter was minimized. Well, actually, I didn't, just assumed. Cheated. We're supposed to plug it in, right? If we take the derivative again, of perimeter, that would be negative, no, positive, actually. 64W negative 3, right? Plus 0. So if I tested, actually just plug it in. make a note here. To determine using in order to determine the width of 4 feet maximizes the. Oh, we forgot the question. Dang it. Minimizes. That's the goal. Given an area of 16 square feet, find out the dimensions and minimize perimeter. Okay. So before I use the first derivative test, so now we'll use the second. That'll be 64 over 4 cubed, right? Which is positive. This means width is 4 feet, length will be 4 feet based on the algebra up top. So we should do this first, but I knew it had to be this because it's the only solution. So I skipped it, but I shouldn't be doing that. Anyway, any questions on number 2? Forgive me if that confused you. Okay, let's do one more for optimization. All right. So we have a piece of cardboard that is 14 inches by 10 inches. And we will cut out the corners and fold it up into a box. So determine the height of the box that will maximize volume. All right. Can you guys picture that? I'll try to draw it in a second. Okay, so picture a cardboard box and you're gonna cut out the corners. May or may not be a rectangle, or sorry, a square or not. I don't know. But we're gonna cut out these little edges here and here. Here. These cuts will be equal. And you're gonna fold it up, right? So you guys agree that these cuts will determine how high you fold it up, right? So we'll say that we're gonna cut this H length. So this would also be H, right? H. H. So what formulas do we need? Because I'm not going to tell you what formulas to use. You have to figure it out. What do y'all think? Well, they said maximize volume. Which volume formula would you choose? Yeah, rectangular prism type, right? Okay. And they said that it is 14 inches by 10 inches. Before the cuts. So if I cut them, what would be this side? The ones with the cuts. Suddenly. Isn't this 14 minus 2h? Does that make sense? See what I mean? So what does this side have to be? Yeah, 10 minus 2h, right? Okay. So length is equal to 14 minus 2h. Width is equal to 14, I'm sorry, 10 minus 2h. That makes sense? And see how we can now substitute it and get it all in terms of h, which will then allow us to focus on height. All right, you guys still with me? All right. So volume is equal to length times the width times height, which is equal to 14 minus 2h times 10 minus 2h times h. Multiply all this garbage, and you'll end up with this guy. Let's skip the algebra, just save some time here. In space. Multiply all these three factors. You'll get this. So dv dh. So this will be 12h squared minus 96h plus 140. Okay. You guys still with me up to this point? But you see how we chose to get rid of volume with respect to h. We got all in terms of h because they want to know what height would maximize volume. So that's why we set it up this way. Okay, just let me know, because I know this is a little more in depth, but we're applying all the stuff we've talked about. So set dv dh to 0 and solve for h to find the critical numbers. Okay. To save time, I'm going to skip the algebra here. Let me know if you want to see it. Not a big deal. Solve this using quadratic formula, and you will have two h's. Right? You would do this. I don't think it factors pretty, so you got to do this. So this will give us a height of 6.08 and height of 1.92. So we have two critical numbers that are both positive. So we need to test both. I think second derivative test would be best. But you could just do the first, I guess. I don't know. So use second derivative test to determine maximum slash minimum. All right. Second derivative is going to be 24h minus 96, right? We could take the derivative of this guy. Get this. Now find out which one is a max and a minimum. Hmm. So this will be 49.92. Negative 49.92. Let me double check this. Double check this number crunching here. Yeah, that's right. All right. So since the second derivative is positive, that means concave up. And we said that will represent a minimum. Concave down. Maximum. So we should cut those corners to be about 1.92 for the box. So each corner should have this square length and width. Does that make sense? The dimension of the cutout. All right. So we found which one creates the maximum volume, which height does, I mean. Plug in height equal to 1.92 into the volume formula, V. Okay. So once we plug it in, we'll know the exact maximum volume that we can create with that piece of cardboard. Let's skip the little algebra here. It should give us 120.164 cubic inches. All right. It's not too bad.
When we're doing the test part, it doesn't matter which derivative we use. The first test derivative, or should we use the second test?
Well,
Second
yeah, it
derivative.
doesn't matter. I recommend the second one if your function is simple. Like notice how this one, the volume function was just really easy stuff, right?
Yes.
First derivative is no big deal, so the second will be easy too. So you can just use that instead of using the first derivative test, which requires you to plug in multiple points. On this one, it's easier because once you have it, you just plug it in once and you know exactly what it is. See?
Okay, I see.
So that's my recommendation, but if you want to use the other one, it's fine.
Okay, thank you.
I recommend you use the The second, unless finding the derivative is just a real pain, then don't do it. Do the first derivative. Okay, so that is optimization. You guys have any questions on optimizing functions?
I have a question. After you did the second derivative test to find your max and minimum,
Mhm.
why is it that you ended up picking the 1.92 to plug into the volume equation?
So that's the one that created the maximum.
Okay.
Maximum volume. Right here, right?
Oh, okay,
Plugged
so
into the second.
asked for the maximum volume. So if it asked for the minimum, you pick the other one.
Yeah, I know the question was a long time ago, right? But let's go. What we were trying to do was get a box, figure out how much to cut out. That way we can contain the most liquid. And we figured out that it needs to be, you don't want to cut out too much because then, the box will be smaller but higher. So you got to cut the perfect amount. And it turns out you want to cut this much.
Okay, thank you.
Mhm. All right. Move on to differentials. This one's very straightforward, so I don't want to do too many of them. Maybe just one or two questions. Well, yeah, like three, I guess. Okay, let me open the homework. I already forgot what this was. 1 second. What the hell? Where'd it go? Oh, here it is. I guess while I'm here, let me extend the homework one more time. April. Today's the 4th. I'll change it to the 10th, I guess. In case you have questions on Tuesday. All right. Yeah. I opened up a bunch of them. Hope to try to help y'all out. Now let's go to differentials. All right. For one, it's just tangent line stuff, so I'm not gonna worry about that. Um, let's do number 3 on differentials. Okay. So the formula we're going to need is delta y that is equal to f of x plus delta x, which is a differential piece, minus f of x. dy will be equal to f prime dx, okay? So knowing that, we'll start number 3. So they said, what did the question say? Find and compare delta y, or the differential, and dy. Excuse me. Y is equal to 0.4 x to the 8th. X is equal to 1. Delta x will be equal to dx, which is equal to 0.1. Let me double check I wrote that right. Yeah, so that was given to us. So they want us to find delta y and dy. That's it. So delta y will be equal to f of x plus delta y minus the original function. This is really formulaic. Plug in your x, which is 1, right? Plus delta y, which was, I'm sorry, delta x. This should be x here. Minus f of x. So find f. Actually, x would be 1 right here. There we go. 1.1 minus f of 1. So that would be 0.4 times 1.1 to the 8th minus 0.4 times 1 to the 8th. So just plug it in. That's all we're doing. Calculator says 0.457. So just when it asks for the differential of y, use this formula. They have to give you the x and the delta x. Okay. So now do dy. dy will be equal to the derivative times dx, which will be equal to 0.4 times 8 times x7. Plug in your x and your dx. And you'll have your dy. So in the homework, that's all they want is find these two, your differential y and your actual dy. I think they want like 3 decimal places, so just be careful. That's pretty much all you're really doing. You're comparing the more approximate approach here, using the differential versus the exact, more of a, got the term, not necessarily exact, but this is more like a numerical approach versus like a, I forgot the term. Yeah, I guess exact is the closest to term. It's kind of like when you have a fraction versus a rounded fraction, you know what I'm saying? Approximation versus an exact number. So this is more, this should be more accurate usually, but they just want you to do both and compare them. That's it. But all you're doing is plugging these two in. to the homework. So there's a couple of those types. So let's move on to a different type. Let's do number 5. That one's different. So show you how to do number 5. This homework's super short, so that's kind of nice, right? The last two homeworks before this will be long, so kind of a nice reprieve. Find the differential dy of y equal to 3x squared minus 7. So basically just do the derivative of both sides with respect to y, or sorry, x. So dy dx is equal to 6x, right? Multiply both sides by dx. Get to here, right? Because they want the differential, so there it is. But we kind of already had the formula, so you didn't have to do this. Remember that dy is equal to the derivative of f times dx, but this is how they get it. But that's all they want. They want this. You guys have any questions on this, on how to do these two types? I don't think there's any other types of questions here. Yeah, they're just different functions. You guys have any questions on optimization or how to do these two types of differential problems? I know it's a lot of ideas. All right. All right, we'll stop here. Let me see the schedule here. So next week, 4, 8. Yeah, I think we're ahead. So next week we'll just do review and give you time to take the test. Test 3. And we'll go from there. And I'm still working on your test 2. I'm a little behind, so forgive me. Hoping to have that real soon. We take roll and we'll call it a night. All right. Is Balkis Ascar here?